Okay, so we're gonna do two things today. I'll try to keep it short. So we're gonna go through what we think should be the next generation of DeFi or open finance applications and what role privacy is gonna play in it. And then we have a couple of slides. I have a couple of slides around what that means from creating a sort of confidential version of Compound and what are the benefits. And then the remaining time, if you have questions or you just want to push back or provide feedback, that's super welcome, okay? Okay, you probably heard this story before, but just to set up the context here, if you think of the current financial system, it's actually based on status, wealth, and geography, which means that if you don't belong to certain classes, you have certain status or certain geographies, accessing the financial services or the financial system is pretty complicated, which means that often you don't really have access to that. And what open finance is bringing, that's why we love it to call it open finance and not really DeFi as much as possible, is that it doesn't matter who you are at all, but it only matters if you respect a series of rules that are established from a mathematical point of view, okay? So the institution set up some rules. If you respect them and if you're in that rules, that's cool. If you don't, you don't have access to that. But those rules are less related to where you live, who you are, and what's your financial history for the last 20 million years. So I don't know if you know, those are the numbers. I don't know if you know them, but 2 years ago, there was only a little bit more than $1,000 locked in open finance. And now on September 19, around $500 million are currently locked in open finance. This is again, not really to say that DeFi is doing great, but just to provide some reasons to believe that in the future it's going to be brighter and that is growing pretty fast. However, when you think of the first generation of open finance protocols and apps, what's going on, right? Like if you have to sum up in 4 points, what is happening that is pretty much focused on protocols and primitives. It's only built for crypto enthusiasts. It's completely public, and the performance is pretty far from being ideal, and is bounded by the Ethereum throughput. So think about the real financial system, right? Think of a couple of examples. In collateralized lending, institution participation is publicly available, which means that you reveal all your money activity to the network. And it's not that hard to move from a wallet to a name when it comes to moving a lot of money. Stablecoin, which is this promise of converting fiat into a digital unit. If you want to use it for the real world, again, scalability is pretty much an issue because it's really slow, and not really suited for the real world at this stage. Even when you go to some very specific trading activities for crypto people, you have decentralized exchanges or dark pools, and money managers are not really able to protect their strategies or the order book. This is subject to a lot of manipulation. This is subject to revealing your strategies, and so it's pretty clear that there is some missing step. There are some missing steps in between the current situation and the ideal one for the real world. But even when you move to another domain, which is compliance, the current financial system is really dominated by legal people, right? Contracts, pieces of paper, rules, expert. They absorb their liability. They do whatever they have to protect the entity they work for, but they're expert in the subject. Now what is going on? Everything is moving to developers. So the power is moving to developers, which by definition don't really have any expertise in dealing with compliance issues. And so we need to think of these people as a way to reduce the amount of effort and the pressure that is on them in case of bugs or information leakage, etc. So this is where we are as a company. Outside of open finance, we are a general privacy-preserving cloud computing platform that allows confidential smart contracts. We are based on 2 building blocks. So one is the blockchain, and the all decentralized aspect of every blockchain. But the most important part is the secure computation, which means this ability of running operations and data inside a secure enclave that runs the application in a safe, secure, and private way. Everything is can be adapted to the application specifically, so it allows full privacy or full transparency depending on what the application is. We're now announcing that, we're starting to announce that we are investing in open finance, and we're approaching open finance at a platform level. So the idea is creating a platform that allows developers to write decentralized applications that keep the data confidential while making it extremely easy, or as easy as possible, to integrate protocols, primitives, and other services. So the building blocks of this platform are four: privacy, scalability, composability, and identity and reputation. Let's start having a quick look at what privacy means here. As I quickly said before, the idea here is having an application, whatever application, that runs on some data and returns an output. The difference here is that everything, data and application, run inside a secure enclave, which is this sort of black box, is probably the best analogy, that allows the computation to run inside it, and only the output is released to the people that are allowed, or to the entities that are allowed to see the result of this calculation. So it's sort of oversimplifying here because it misses the decentralized aspect, but this is decentralized, this piece. Yeah.
Technically, how does it work? Is it just a piece of hardware, or this is just a cryptographic solution?
Yes. So, yes. So the question is whether it looks like a piece of hardware or a combination of cryptographic techniques, right? Yeah, it's both. So it's multiple pieces of hardware because, like, nodes need to, some nodes at least need to run on the Intel SGX, and the combination of cryptographic technique comes handy when it comes to managing the keys for accessing that. So it's a combination of both. And the result, the reason for that is that we want to allow for performance, but at the same time, we want to reduce the amount of trust that we put on the piece of hardware. So a good analogy here is if I need to compute the average age of people in this room, what do? I have kind of two solutions. One is I go one by one, ask your age, and then return the output, but I'm the information holder, so I can send it somewhere else. Or I hire a third party that goes to you, asks the question, say, what's your age? And then does the output, does the calculation, returns the output, and hopefully destroys the data. In this situation, the analogy is I put a black box here. You come here, you put your age inside, and this black box only returns the output. Clearly, this example is oversimplified because if you hack that black box, everything is gone. So that's not a real analogy, but that's the idea behind that. So when we add privacy to the financial system, it's kind of like mimicking the real world financial system right now, which means that participation of company and individuals in a financial activity can be kept private. So when you go to your HSBC bank and ask for a mortgage, that information is not publicly available, so why should it be in blockchain? When it comes to like strategies and trading strategies, order book and trading strategies can be hidden. So only professional that deploy the strategy can actually access that. And the manipulation opportunities are significantly reduced. Like front running is the most obvious one, and it's not possible if the system runs on a private enclave. Okay, scalability. The second topic that we really care about is scalability. You guys know that Ethereum has a throughput of 15 transactions per second, pretty far from the 1700 of a payment network like Visa. So this is the first limitation. But at Oasis Labs, we also think that scalability is much more than transactions per second. Because transactions per second only means, I don't know, like me sending money to someone else or like very simple transactions. But effectively, in a world where a lot of applications require some machine learning or some rebalancing of parameters, which is very specific in DeFi, like for instance, as a result of supply and demand, as a result of how the interest rate is calculated, you effectively need much more than just number of transactions, but you also need to account for the complexity of the transaction. So in a world where, for instance, you access with a token, you lock this token in a private escrow, there is some insurance player involved to effectively factor a credit scoring and then run some machine learning, you cannot allow for just transactions per second, because that would not be able to work in a world where you only have speed and you don't have complexity of the transaction. So somehow we think that scalability and TPS as a measure of scalability is effectively a inferior measure for scalability. So we try to understand both. We try to chart both TPS and complexity and try to be top right as much as possible. Okay? The way we do that is separating the 3 layers of compute, storage, and consensus. So when you think of Ethereum, for instance, every node runs every operation, which makes the network super slow. It seems that this is not really required to achieve decentralization. So you can have different nodes that perform different applications. Again, compute, storage, and consensus. Each layer can be scaled independently from the other. And we can still embed privacy at each of these layers. So that's what we do. We have different nodes that perform different operations. One of the biggest problems in open finance right now, or if not a problem, at least one of the biggest questions is how to compose different protocols when it comes to create a user-friendly application. So these are just 3 examples pulled together in Startup and Flux. They use multiple protocols, and these protocols have been built independently, sometimes on the same platform, sometimes not. So how do you account for that? How do you make sure that these protocols work together in a seamless way that can enable developers to really focus on the application and not on the interoperability of these protocols? So our vision for that is really understanding the developers. At this stage, I don't know how many of you are developers, but it's not completely hard to understand that the process for these developers is something like that. So there's a discovery phase where they go through, okay, I need an oracle, what is the best one? Or what is the most suitable for me? Then that implies reading documentation and finding ways to integrate that. Sometimes it's easy, sometimes it's hard. Then there's a process of evaluation, which means, I don't know, like, am I ready to spend more for a transaction, or I'm okay with having less fresh data, for instance. And then there's the whole process of integrating that. We try to make this process extremely easy for developers, or at least as easy as possible, and that's how we envision our platform. There's going to be a network, which is going to be a layer 1 here, which is the Oasis network, something that we need to do anyways. And then a series of applications and a series of primitives and integrations that will allow developers to build an application on top. So we're building a set of open finance primitives, from compatibility with ERC20, two-way pegging, lending contracts, and buy-sell orders, etc. We are making it easy and integrating and signing partnerships with a lot of protocols, primitives, and services in order for them to be consumed on our network in a seamless way. And then on top of that, developers will build the application. One important aspect to mention here is that we are thinking of ways to enable ERC20 holders, token holders, like Ethereum holders or DAI holders, for instance, to be able to operate on our network without passing through an exchange and swapping the token. So some two-way pegging solution is probably the way to go, at least in the short term. We'll see later. But the idea is enabling the existing liquidity and not asking users to create a second liquidity for everything that runs on our network. So back to the composability and what that means from a developer standpoint, we are building this dashboard where you can log in as a developer. You can pick the category that best suits you for a specific need. And so you say, okay, my application will need an Oracle, we need a stablecoin, we need a wallet, and we need an exchange, for instance. So you click on the category that you need. And then you have a series of pre-integrated protocols that you can add to the platform. Right now, we don't support the application logic, so you cannot really create the if-then situation, but you can deploy contracts with a couple of clicks. You don't have to go through the documentation of the other service. You don't need to read the documentation there. You don't need to understand how it works. You just click this small plus, and the contract is then deployed. And this is only one of the pieces that we are putting together for developers. So when it comes to building the application, we have our own SDK, and we are offering support for Rust, which is effectively what we're going to use for embedding privacy-preserving contracts. When it comes to the deployment, we'll make it easy. We are making it extremely easy to deploy your contract from Ethereum to our network. You just change the faucet and pretty much it. That operates under the WASM runtime. And then when it comes to managing, the dashboard that we just saw will be extremely relevant for developers, but also a set of analytics that shows how your product is used, what contracts are called, what users are leveraging in your platform, and so on and so forth. So everything in one place. The idea here is that if we make it easy for developers, that will make it easy for users. And then the last piece is identity and reputation here. So again, stepping back and analyzing what the open finance is right now and what it should be tomorrow. We are today in a situation where majority of open finance, around $420 million out of the $500 million that we saw before, involves some single asset over collateralization, which you probably are all familiar with, but this is the ability of locking some amount of Ethereum, retrieving some lower amount of DAI, go somewhere else, trade the DAI, and then reverse and close the position and capture the profit on the Ethereum growth plus on your activities on the DAI. This is more or less what it is right now. The KYC is happening here, which is this ability of verifying the identity of people, attesting that a user is effectively that user and nothing more for some of the application. But the biggest point, will be where we can move from over collateralization to under collateralization. This is where open finance will see probably mass adoption. And in order to do so, what is missing in the market is a reputation system. In other words, when you go to a current bank and you say, okay, I want a $10,000 mortgage, you need to provide some data about your history. And based on that, they say, okay, we're going to give you this money if you collateralize something, which may be liquid or illiquid, depending on the situation, but it's generally under collateralized, because otherwise they wouldn't be, at least on a cash standpoint, on a liquid standpoint, it's definitely under collateralized. So how do you do that? How do you create a reputation system? We don't know yet. We're studying that. We're partnering with other companies to find the best way to do so. But the idea is, you can now, in the current situation, you can open good accounts on one wallet and bad accounts on another wallet. And so you can serve your history in different ways, which is not really ideal for saying, okay, you're a good customer or a bad customer. And so we see a world where your identity is effectively a combination of a lot of pieces of information. That's your financial history, maybe your sharing economy, maybe your work history, etc. And we're thinking of ways to enable this identity to be portable and owned by the user. So if you think of the current credit score, which is just a number that comes out as a result of some of the activities and is related to one specific geography, we want to do the opposite. So we want to leave the data with the user and then allow the user to share this data with entities that need that in a confidential way, so that the credit score is not a number decided by an entity, but it's effectively a model that is decided by a certain company. So you are a mortgage provider, you decide what's relevant for you, for that specific user. And so you say, okay, if the user has a certain set of rules, for instance, okay, I issue this loan, otherwise I don't. So let's consider just an example of this John that wants to get a loan for his new beautiful car. and maybe needs to provide, I don't know, like some of the information, total compensation, current mortgages, where he lives, is the attestation that he's a U.S. citizen, plus the amount of cash. I don't just an example. The company that issues this loan only analyzes some of the data, runs whatever model they decide to run, and issue a reputation score. So it's okay, 92% for John. This is not something that Experian does. This is not something that a central entity will do, but it's a queryable way of calculating a risk profile based on the model that works for that specific company. And based on that, this company will probably issue a 92% risk profile, and we're going to issue that loan at a certain rate that depends on these categories. The cool thing is that these parameters here, when they change, they will immediately change this and probably change the amount of or the term of the loan. So John is incentivized to have a certain behavior because otherwise the conditions will change. Again, it's a little bit up in the air at this stage, but this is what we are working towards. The most important aspect is being decentralized, programmable, and then private, and stays with the user. Okay, let's bring everything together, and then we go through a couple of slides to demonstrate what privacy is going to change in a compound equivalent product. So in the current system of open finance, when you add privacy, we said that you bring it to real-world adoption. Again, the analogy here is when you walk into a bank and ask for a mortgage, they don't stream this information to the market. So why should that happen in open finance? When you add scalability, you make open finance suitable for the real world. Because for now, even if an entity, if a big player wants to transact at scale, it wouldn't work. That's the reality. When you add composability, you make at least developer-friendly apps, and hopefully user-friendly apps as well. And when you add identity, which is mostly reputation than KYC, you allow under-collateralization, which is the primitive of every financial product in the world. Okay, so what if we had a privacy-preserving version of Compound? And again, here it's oversimplified, and the scope is demonstrating where privacy can make a difference. I don't think that any of you wants all the financial information to be exposed to the public, and I think that in an ideal world, you want the information to be with you and being queried only for a specific example, right? And also, what's your tolerance for manipulation? If all the data is public, that clearly creates an opportunity for people to manipulate the market. Okay, so these are the, I suppose you're familiar with Compound, at least from a user standpoint, but maybe I don't have to go contract by contract. We really didn't know whether the audience would be technical or non-technical, being called workshop, so we did a little bit of both. But in the Compound, maybe oversimplified, the idea is creating this fake O token, which captures liquidity from Ethereum, converts for a two-way pegging, and allows to run on our network without any complication for the user. And there are 5 main contracts. Mint, which means that whenever you transfer your asset into the money market, this contract is called. Redeem is the opposite process, from the money market to you. Borrow is transfer underlying asset out of the market. Repay the borrow is clearly the opposite, and then liquidate is just closing your position. And then there are other contracts that serve as helpers, let's say. So this is the interest rate model, which is a supply and demand. Get underlying prices just returns the price. And then there are other things like controlling plus oracles, etc. This is the Compound structure. This has nothing to do with us. Clearly, Compound is operating with different services like oracles, etc., so they need to make sure that they don't rely on external services that are centralized, which poses another challenge. Someone yesterday was mentioning the importance of privacy in oracles, which is also something that we are exploring. So how does that work? From the lenders, they supply an underlying asset into the money market, and then the interest is accrued, and when the person wants to cash out, the person cashes out the initial amount plus the interest. That's, again, pretty obvious. For the borrowers, they supply the underlying asset into the money market. They borrow from any available money market, and then they repay borrow eventually. And they can liquidate the collateral borrowers in red, of course, because it's over-collateralized. Okay, this is what a privacy-preserving version would look like. In the current system, whenever you pass one of these contracts, this is just the mint contracts, would be the same for all of them. There's a set of information that is associated to that. The to, the from, the gas data, the gas and the data. And the data is what method is called, which in this case is mint, so this function that moves money to the money market. So you're streaming to the market, you're telling the market that you're moving the money from source to destination, and then the amount.
The source here is like a different network, or what is the source?
So the question is whether this is in a different network or where is the source. So this is the Ethereum model. So this is as simple as compound. But this is kind of the same thing, whether it runs on our network or not. The thing is, on Ethereum, you cannot make it private. So when the scope of this illustration is to show that whenever this transaction happens, this mint contract is called, which again means that you're moving the money to the money market from your wallet. You're telling the market, hi market, I am calling a function mint, which means source to destination, and I'm moving this amount. And this is me, lender one, and this is how much I'm paying for this transaction. This is the current situation in Ethereum. And the equivalent is you're walking to us, before walking into the HSBC bank, you tell the market, hey, I'm going there, and they can adapt. They can potentially adapt the interest rate based on that, right? In our model, this is the encrypted version of that. You only see the from lender one, but you don't see what's going on because everything is encrypted here. So you don't tell the market what you're doing. You tell the market that you're doing something, and there are ways to prevent that. But you're telling the market that you're doing something, but you don't tell the market if you're minting or borrowing, or because what the market see in this case is a mint function and the amount, or a borrow function and the amount. In our world, you only see a string of numbers.
So you can still see that it walks into the bank, but you don't know what he's going to do.
Yeah, but there are ways to obfuscate that as well. So this is not the main concern right now when people refer to privacy. But this is still changeable. You can apply multiple layers and change that. So the answer to your question is just in this slide. In reality, you can avoid that. But the biggest difference in these two words for a real usage is this thing. You see, whatever happens, you see a string of numbers.
How do you send the money in the first place? I mean,
Sorry, can you use the microphone?
Yeah, I was repeating the question, but yeah. Thanks.
so how do you send the money in the first place? So let's say I have a million of DAI, okay, publicly. And then I need to transfer this million of DAI to the market or to your system, yeah? So this has to be public, right? The first.
There are two ways of doing that. In the first, if you have DAI and need to access our market, in the current model, yes, because we need to do a pegging there.
Yes.
So the answer is yes, because you need to lock it in a random smart contract on Ethereum. The other alternative is that you're token holder of our token, and so in that case, no.
Okay. So
Because
if I
you
prepare
don't
a
see
token in your system, then
right. So there are two different situations here. So your question is actually your question has to be decomposed into segments. One is the scenario where you are a DAI holder and you say, I don't want to bother with switching to the Oasis token. Okay? And in that case, we cannot help you because you need to signal that you're converting one to the other one. At least in the current situation, we are studying a privacy-preserving version of the two-way pegging, but we haven't figured it out yet. But the second case, which is I have Oasis tokens, in that case, no. So the first part of your question can be solved through a privacy-preserving decentralized exchange.
Can you describe in more detail how the two-way pegging works? I mean, what are the trust assumptions? Do I need to actually trust you as an operator of the bridge, or have you kind of figured out how to do it in a decentralized way, or essentially you're like an operator and need to trust you entirely?
Yeah. No, we haven't figured it out. So I can give you a high-level answer of what we have in mind, but we don't have the full model in place right now. We're also debating whether we should partner with existing solutions that are coming to the market. They haven't announced it yet, but there are 2 or 3 companies that are providing a two-way pegging as a service, let's say. But overall, the level of trust effectively doesn't have to rely on us, because the idea is as follows, and you probably know that already, but you have Ethereum on your wallet, and so you can lock this Ethereum in a smart contract on the Ethereum network, which is not owned by us, right? It's just still decentralized. And then we create an equivalent version of some fake Oasis token just to run on our network. So as soon as you lock, let's say 100 Ethereum, we create 100 Oasis Ethereum, let's say, that you don't even see. So you run the computation on our network whenever you have to do, and when then you go back, we burn this 100 or whatever, 100 plus or minus your activity, and the contract releases the equivalent of Ethereum to your wallet. Does that make sense?
Well, it doesn't answer my question.
Yeah, no. Because your point is
Well, the idea is clear, and I do realize how current bridges work, like with
Exactly.
POA networks and whatnot, and this is what you described. But my question was about the trust assumptions, right? Because frankly, if I do that and I still have a control over my Ethereum that I've locked, I can unlock it any time. And at the same time, your token that you created on your network can be used as a whatever, I don't know, collateral or whatnot, right? And suddenly I've got double spending here clearly. So there must be some other way, of doing this, because I shouldn't be able to lock my tokens and then unlock it at will, right? So the question is, who is able to unlock my token? And if it's you, then suddenly I have to trust you, right?
Right.
That you will do it when I ask you to do so.
Right.
And you
no,
don't.
Of course. Like as I said before, we're now selling ourselves as experts of the two-way pegging. We are researching into solutions to make it available, not to ask user to swap liquidity all the time. But we are not coming to the market saying that's our perfect solution. So clearly, there's an Oracle problem even there that we are trying to.
Okay, so maybe just unrelated to the question, because I do realize that two-way pegging, it's a complicated issue and it's not properly solved yet in the decentralized manner. But let's go back to your example about the privacy.
Yeah.
So, clearly I see that there's this big trade-off here, because my transactions are private, and that sounds like it's a cool idea, but I'm losing the transparency. I cannot really say what's happening, at the contract level in the bank, meaning that, are they having full reserve, or maybe they ran away with my money. I don't know the balance, it's like on the whole Zcash, right?
Yeah.
If Zcash is hacked and someone is able to mint tokens on the Zcash network, no one would know, because you don't know what is the total balance of the system, because it's kept private, right? So how do I actually monitor the system that actually works as intended? That's
so we have two marketing problems as a company. Challenges, I'd say. The first one is making it clear that when we refer to privacy, doesn't mean that everything needs to be private. You specify, you meaning Dapp, specify what needs to be private and what doesn't. So it's not a property of the network to be fully private, but it's a choice that we offer. So theoretically, you can have everything public if you want, even if you run on our network. So the DApp, in this case the central bank, the decentralized bank, will decide whether they will market themselves as the transaction is confidential but the balance is public, or something like that. So they have full choice. So we go from fully private to fully public. So this is the first part of your question. The second one is, even in the private version, so assuming that you decide to go private, how do we demonstrate that we don't have access to the things that you were saying? In other words, if I tell you I cannot unlock that door, how do I prove that to you? And an easy answer is we are hiring audit companies to do that, and we are.
Like Tether.
We're hiring more than one, but yeah. But yeah, this is a question that have been asked before, and we're trying to solve that. It's not an easy answer, but this is like less of what you ask. It's some information that is going to be important for a network in general. When it comes to the first part of the question, again, I want to underline here that we allow full transparency or full privacy, depending on what the application will look like. So you can have exactly this model on our network. That's the biggest difference with the others.
Can we ask questions?
Can I?
Do we have time to ask questions?
Yeah.
So I have two. One is like technically, so this transaction is sent to Ethereum network, and your network is...
This one is not sent to Ethereum network.
Okay, so the encrypted transaction is directly sent to you?
This is on our network. Then if there's a two-way pegging situation,
so
in that case something will be...
It's going directly to the Enclave?
Yeah.
Yes, and second question is like related to the previous one. So I guess now in the first iteration, the first version, there is no way how we can create a new service by our own, correct? We only click it from a template, from audited contracts or whatever.
Sorry, say again. There's no way to create a service.
So my motivation for it would be if I'm able to create money market service.
Oh, I see.
Contract. Yes, then how I will prove that? I will really keep the arithmetic correct. That if the bank is sending the money, it will be really debited.
Yeah. Well, so we have a full consensus layer and full decentralization there. So nothing that we've seen so far relies on a central authority or a central entity that says yes or no. If that answers your question.
Well, the contract,
yeah.
Money market service contract.
Yeah.
Is encrypted also, right?
Yes. Okay, but the nodes can run the computation inside the secure enclave. That's the whole point. Like there is a consensus.
Yeah, but if I don't know the contract, the body of the contract, then I can't trust it.
Yeah, but this is the property of the secure enclave, is allowing the computation and making sure that computation is verified, even in a private way, in an encrypted way, because what happens is that the data is encrypted inside this enclave, and so you can see, you can run the computation, but you cannot see the data inside.
I mean, it didn't fully answer the question, but I got the idea.
Okay.
My question was like, how if there is some random service, what checks I can do to make sure that this works as intended, as they are marketing
but
it.
Who are you? Like when
I'm
you say
a client.
Oh, you're a client. Okay, that's what I get. Well, this is the point. Like if you trust the consensus layer, that should be the reason why you trust the blockchain, right? But if I open the data set to you, that would be opening the data set to everyone. By the way, I cannot even open that. The person that runs the application will do that. But so in some cases, we got similar questions sometimes in analytics when people say, okay, we enable like private analytics. We want to do private analytics there. How do we know that my computation is right? This is not a property of the technology, but it's going to be a decision of who runs the computation. So in the analytics space, someone says, okay, I'm going to open 1% of my data set and show you that data is right. I mean, this comes on a trade-off based on what you need to get and give in order to show that your computation is right, for instance, versus measuring your performance on how many complaints you get, for instance. So this is a trade-off from the application. But it's not something that we decide at blockchain layer. Yeah.
So my question is related actually to the secure enclave. So you say the compute runs in the secure enclave, which runs on the Intel SGX. Mm-hmm. And as far as I'm aware, Intel's the only chip manufacturer that creates that type of technology. How do you evaluate, the risk associated with relying on one hardware manufacturer? Yeah,
good question. So Intel is not the only one that creates a sort of secure enclave. We are creating, there are different companies that are doing that. AMD is one of these one, for instance, and they have a trusted environment, I think. I can't remember the name, but it's a competitor of that. And we are a company that comes from UC Berkeley and Stanford, and a group of professors from UC Berkeley, Stanford, and MIT are also creating an open source enclave, which is called Keystone, which you can go and have a look at. So we are prioritizing Intel right now because it's the industry standard for that, but there are alternative solutions. So your question is very good because effectively, how can you rely on one piece of hardware and being decentralized? So the intermediate answer is there is a set of decentralized key management that significantly reduces the reliance on one piece of hardware. But plus, there is the secure enclave keystone, which is open source, that many people are working on and accelerating, and we're planning in the future to also integrate different solutions. Just in spirit of focusing, we need to prioritize something. Yeah. Okay, so we are getting to the end. We released a blog post a couple of days ago. In case you want to see that, I just made this easy link. We just repeat the same things that were in the slide. If you want to put some claps, that's like shamelessly asking for that. And we, as a company, only have 3 asks for you. So the first one is, if you want to build an app or integrate your service or simply share feedback, we are super open. So please let us know. And here's my email and Twitter.
I have a question.
Yeah.
How do you guys position from, I guess, a strategic perspective in the ecosystem, in the development ecosystem? Are you looking to attract developers away from Ethereum to develop on your platform? Are you fully compatible? What's the sort of...
Yeah. So in the short term, we are fully compatible. So you can port your Ethereum application there. I'm not sure we see ourselves as Ethereum competitor. We think the space is really too small right now, or potentially too big to really talk about like being competitors. I think companies are coming to the market solving specific pieces of the financial system. Like you probably heard other talks yesterday and today, and everyone's coming with, I don't know, synthetic or oracles or identity. Like everyone's coming from a piece of that. We don't have that capability. Our core strength is privacy and privacy and scalability. And so we think that the platform approach will be our differentiating factor, at least in the short and medium term. That will allow us to see where the market is going from a layer 1 perspective, and so get information on what companies are doing, what developers need, what users want from that layer. I don't know what the future is going to be. Probably no one knows. I mean, we have our own vision and roadmap that we showed before, mainly from over-collateralization to under-collateralization. So we think that the missing steps are privacy, identity, reputation, and maybe insurance, which is like getting more and more traction. And in terms of, if you want to draw an analogy with Ethereum, there are maybe like 2 differences. The first one is our properties, again, privacy and confidentiality. And the second one is being more DeFi specific for that vertical, on top of being a company rather than being a organization. But again, I don't think seeing ourselves as a competitor with Ethereum is the way we interpret that day. Hopefully we can like work together and advance that space. In the longer run, we think privacy is going to be really key for real-world application, and so we think there's going to be a shift. I mean, right now, priority is probably figuring out what DeFi is, attracting users, and building credibility of that. But at some point, privacy will be a very important need. And we are hearing from probably like 30, 35 companies that we talk to that privacy is their next thing that they're going to use to attract users and to make applications.
And so you don't think that, presumably as a company, you don't think that the initiatives to build privacy on top of Ethereum have a future, or what's your take on that?
So we think right now that embedding privacy at layer 1 is probably a better choice than at layer 2, because of the nature of privacy. Exactly, and scalability as well. That's what I was saying. We live in a world of data, The efforts in open finance or in DeFi for us is pretty new, but we still think that the machine learning and the computation on private analytics will be the future as well, even in open finance. And that's where the scalability becomes super important, much more than the TPS, as I said before. So those are all valid points. We have our own vision. We cannot be certain of that, of course. But we think that layer 1 answers this question better than layer 2.
So what's the idea of the network setup? Are you seeing it as there will be like many permissioned per blockchain, permissioned networks?
No.
Are there will be like a one? Is it possible to set up a private network? Who is going to run the node? What's the incentive to run the node?
Yeah, we're figuring out answers to majority of these questions. We're probably releasing our our next 6 months are going to be answering all these questions, including different releases of our mainnet. No permission network. The network is going to be permissionless.
Will you support it? I mean, if there will be an institution which would like to run a permissioned?
We don't have anyone asking for that, and we don't have any yes that we said when they asked us. The other part is the incentive. We are recruiting stakers now, so we are designing the incentive plan these days.
Okay, so that will be proof of stake network?
Yeah.
Mm-hmm. And
with a rotation of the committee. I'm happy to give you more details later,
okay.
but yes.
And what's the current state? What's the roadmap?
Roadmap 4.
Deployment. I mean, is it production ready? Is it?
It's not production ready right now. We have a DevNet up and running that you can use and play. We have a dashboard in place so you can go and use it. Not for open finance. You're going to find more generic smart contracts deployed there, so you can do it. We are announcing the timeline in the next few weeks that it will include a basic version of a mainnet, then a version that supports smart contract, and then the privacy.
Okay, can you share the idea? When do you expect to have
No.
to be production ready?
Yeah, early next year. Production ready early next year with smart contracts and privacy.
With mainnet?
It depends on what you include in the mainnet, right?
Okay.
I mean, look at the market. There are multiple ways of going at mainnet.
And one more question. You said that there will be a possibility, yes, to create a smart contract directly in Rust.
Mm-hmm. Yeah, not just the possibilities is our main. We are a platform that has Rust.
Yes.
And then we are also Ethereum compatible.
Okay.
But Rust is our choice.
Okay.
Yeah. And the privacy features are going to be possible in Rust. Yeah. And we're planning on adding support for other languages as well. But Rust is our choice. Yeah.
Luca, thank you for the detail. I have a question for you because you're speaking a lot about privacy and privacy by design, basically. Mm-hmm. But the point is that how do you think this will be compliant to GDPR? Because I think it is an open question, and it's still something that is not going to be solved soon, as far as I know.
Yeah. So I think I have two answers to your question. The first one is we are a layer 1. So the GDPR, we see it as a layer above, like people that deal with the data. We don't expect ourselves to deal with users' data. So that's one part of the question. The second part is that when we talk about privacy here, so first of all, like there's no privacy-preserving computation in the GDPR, right? It's not that you read the billion pages of the GDPR and you figure out that. But the basic rules of GDPR, from my understanding, and I'm not an expert at all, but there are kind of like two big rules. One is you shouldn't own more data than what you strictly need and are allowed to, and the customer need to have visibility of that. Those are, from my understanding,
there is the possibility to delete the data. This is a big point.
Right. So this is a sort of scenario that is not captured by GDPR in the current model, because in this scenario, there's no ownership of data, right? And there's no visibility of data. Sort of this. So assuming the data lives inside here, right? It's not an employee at a company can go and check the data of someone. Again, this is to say that I don't have an answer to that, not to say that this is GDPR compliant at all. But this is a case where GDPR, like this case is not specified in the GDPR,
No, it is. The
Yeah.
point that you are speaking about anonymity and,
not really.
and privacy preservation, but still there
Yeah.
are some concepts, even if it is layer one,
Correct.
that should be taken into consideration. I
Yeah.
think that's my personal
Yeah.
opinion, is that if you guys can figure it out, also how to solve and to be compliant with that thing, that would be a winning factor.
Absolutely. No, we are having legal companies that are legal agencies that are working on that, but it's not making the data anonymous here. It's not anonymity. It's really not seeing the data, not striping out the personal identifiable information. We all know that with 2 data points, you get 80% of the something like that, right? With only like first name and zip code, you get like the person, something like that. But in this case, you don't see that data. It runs in the data runs in an enclave, so you don't have that information. Not because you anonymize the data, but because you don't make the data visible. And that's one part. From a mathematical standpoint, there is a piece that I haven't talked about, which is the old world of differential privacy. I don't know if you are familiar with that, but it's the idea that, let me give a real world example. Our technology, the basic version, is deployed at Uber right now. You find some articles online as well, because it happened in the past that some of the employees at Uber were checking on other people's trips, something like that. And so they ask us to rewrite the queries that the employees were effectively writing. And so we have a sort of query rewriter from SQL queries that adds some level of noise. And so whatever the output, whatever the input, you're never going to be able to retrieve the punctual data. Again, I don't know how GDPR responds to that, but the distinction I want to make here is that it's not anonymizing the data, but it's securing the data in an enclave where you don't have access to. But yes, if we could solve the GDPR problem and embed it at layer one, that would be a big win for sure.